Welcome to ChemiCuss guys. So today we're going to solve the rest of the problems of BHU PET examination, and today we're going to start with the organic portion of the question paper. So as I've seen the organic portion of the question paper, I have noticed that many of the problems that came in the examination were of like you have to remember the structure or any of the starting materials like that. So they are not really conceptual because you can see that there is no mention of any prediction of product or anything else. Most of the questions are related to some name reaction or the structures or critical structure and color of the organic materials. And so the organic part is really difficult for those who have not worked up the products or the reactants structure properly. So with that saying, we'll start. So first question is which of the following is used in synthesis of fluorescent? So fluorescent is a compound which can act as fluorescent compound, which is an organic molecule, and it is basically made up of resorcinol in reaction with phthalic anhydride. So this reaction produces some conjugated structure which is very much responsible for the fluorescence nature of this compound. So for question number 1, the option number 3, resorption is the correct option. Now moving on to the next one, which is like in case of the following reaction, ketone is a substrate for biodiesel oxidation, because we know that here we use MCPBA or the meta chloroperbenzoic acid as our oxidating agent, which will just incorporate one oxygen near to the carbonyl group. So the starting material or starting substrate is ketone here. Now, so for question number 2, option 4 is the correct option. And which one is triphenyl methane dye? So it is basically the malachite tree. We know that very well because of the structure. And next, moving on to the question number 4, intermediate ketene from. So ketene, we know that ketene is like the same structure as alene, but here we have the oxygen and carbon instead of CC, right? So C double one C double one O. So intermediate ketene from the decomposition of diazoketone occurs in. So we have to tell the name reaction where this kind of reaction occurs. So for option 4, so for question number 4, option 2, Wolf rearrangement is the correct one. We're not going to the details right now because we know that we want to know the answer sheet. What is the answer key? For the time being, we're just taking out the answer key. We'll just discuss some of the important concepts here in throughout the question in our next upcoming videos. Nextly, for question number 5, phenanthrene is synthesized from which one? So for question number 5, the third option is the correct option, succinic acid naphthalene. Anhydride naphthalene is the correct option for that. So moving on to the question number 6, which tells that which position is highly reactive towards electrolytic substitution in acid. So this is the first basic question or the conceptual question I find in this paper for organic part. Now, in case of anthracene, we know that three benzene rings are merged in one molecule, and from that we have alpha, beta, and gamma position. We know very well in case of the naphthalene molecule, their alpha and beta position are very much known, which are basically 1 and 2 positions. But in case of anthracene, what is that? We know that in anthracene, the electrophilic substitution reaction occurs at the 9 and the 10 position, which is just the top and bottom carbon of the middle ring. That's why this position is called the gamma position, not alpha or beta. Rest of the positions are called alpha and beta, and this is the gamma position only. So the for question number 6, we have this third option as the correct option. Nextly, we will move to the question number 7, which tells the reaction of naphthalene with sodium isoamyl alcohol gives. So what is the product? We have naphthalene to start as a starting material. So the option number 3, the 1, 2, 3, 4 tetra hydronaphthalene is the correct option here. Again, this type of question are just directly mug-up type question, because you have to exactly know what is going to happen as a product, and you cannot apply any basic concept there, right? So moving on to the question number 8, oxidation of quinoline with alkaline KMnO4 gives. what is the product for this oxidation reaction where we have this K1O4 as oxidating agent. So the option number 2, quinolinic acid, is the correct option here. Again, I'm sorry that I'm not telling the structures here because we have the time constraint, but we'll surely do the brief explanation in our further videos. Moving to the question number 9, where we have this which of the which one of the following is used for isoquinoline synthesis. This is basically a pictet Spengler reaction synthesis where we start with the amine and then we just move to the isoquinoline synthesis. Right. So question number 9, the correct option is 1. Next, moving on to the question number 10, we have this nucleophilic substitution in choline occurs at which of the position? So we have either two option number 2, that is alpha position, because that is the most electron dense position where we have this substitution reaction occurring, because for substitution reaction we know that there must be some place where the electron density is much higher compared to the other places, while in case of electrophilic reaction we expect that the place where there will be the least dense electron density, so that there will be the incoming electron density from a nucleophile from outside, right? So for question number 10 we have the option number 2 as the correct option. Moving on to the question number 11, which is the like isomers differing configuration at asymmetric carbon due to hemiacetal ring from founder. So this the answer for this one is anomalic carbon. So at anomalic carbon we know that anomalic carbon is the nearest carbon to the oxygen oxygen bridge cycle. So in that, the nearest position to the oxygen, which is called the anomalic position, and the anomalic position creates this isomerism by giving the upper or the below the plane configuration or the substitution of any group or any atom. Nextly, question number 12, we have sucrose is made up of units. So sucrose is a disaccharide, as all of us know that. But what are the disaccharides consisting of the monosaccharides? So the for question number 12, we have the option third as the correct option, which is alpha D glucoside and beta D fructoside. So this is all for now. We'll just move to another section in our next videos. So stay tuned to our channel.